Hi guys, it's another beautiful day, so let's look at another beautiful thing. We're going to talk about IPv6 addressing, how to assign it to an interface and how to assign it to an host like PC. Alright, so and then we will ping those IPv6 address to see if they are properly assigned, and then I will give a deep explanation about then the different type, like the private IP address in the IPv4 and then the public IP address, the name they are called when using IPv6. Alright, so let's look at them. For example, I've already prepared that. These are the two major type. The unicast address. So the unicast address is a type of IPv6 address, just like as we have a unicast address in IPv4 address for one-to-one communication. We also have broadcast in the IPv4, but there's no broadcast in the IPv6. So just like the IPv4 address, we also have multicast, but we are not interested in any of those. So we are going to talk about this unicast address. The unicast address is divided into global unicast and the unique local addresses. You also have link local address, but the two we're talking about basically is the unique local address. The link local address is assigned automatically when you enable IPv6 on any device. Alright, so the global unicast address is equivalent to the public IP address in the IPv4, but the unique local address is equivalent to the private IP address in the IPv4. So since we mostly use the private IP range, which is used for local area network in most cases that doesn't require paying for the address, we will be using that range. So when you talk about the range for the global unicast address, it starts from 200 to 3FFFF. Alright, so this is the range for the public IP address in the IPv6, but we don't call it public IP address anyway. We call it global unicast address when you are using the 10 IPv6. Then when you're using the 10 unique local address is equivalent to the private IPv4. So the range for that one is FC00 double colon to FD FF to all F. So whenever you see any address that begin with FC FD, you know that this one is a private or it's a unique local IPv6 address. Then whenever you see anyone that start with 200 to 3F30, you know that one is global unicast address. Alright, so this IPv6 in particular uses hexadecimal, unlike the IPv4 that uses decimal. So the hexadecimal is another big topic that you must have studied in depth, but basically it uses a combination of both decimal and the alphabet to represent the value above 9. So 10 is A, 11 is B, C is for 12, and so on till 15th. Alright, so let's move further. So I've already decided which IP I'm going to assign to the interfaces. The various section of the IP addresses have name. We have interface identifier. So after the network address, the IPv6 is usually divided into two halves. The first 64-bit is for network portion. The last 64 bits are for the end host. So the end host bit that you'll be assigning to the end host or to an interface is the last 64 bits. Normally there are 32 hexadecimal digits. That is, for example, let me pick this one. All these hexadecimal, you can, if you count them, they are 32. Then they are usually divided into two half. One half is for the network, the other half is for the host. So each of these hexadecimal digits are separated into 8 units. Each separation contains 4 hexadecimal values, and each value is each group is called quoted, while in IPv4 each group is called octet, but in IPv6 each group, like this FFF that are 4 in units, so they are called quoted. All right, so let me go straight to set up the topology that we are going to use. We will use a very simple topology, just a PC router. I will just use a switch to connect multiple PC, maybe like 2 PC, because the PC is just to interconnect the PC, because it's not going to participate in anything here. We cannot assign IPv6 address to the SVI. I think it's because of the packet tracer. I tried it earlier, it was not working, so we will not assign it to the SVI of the switch. So let me go to the PCs. PC here, I will assign to. So go to the connection, straight through, fast Ethernet 0 to fast Ethernet 1. So fast Ethernet 2. Then crossover G01, G00. Okay, so first thing we are going to do is to assign various one to the PC. Let me look at this again. Okay, here is the network address. You know, IPv6 is very long. It's 128 bit. So we normally use shortcut to shorten to reduce the number of typing. Like if I'm to write it in full, it will be longer. So there is an acceptable shortcut to be used where you have a leading 0. That is, for example, there's 0 before this one. To complete the quartet, you can short it by removing the 0 that is not necessary. Then where there are multiple zeros, repeated 0 like this, you can use double quartet, double column like this. That is, this double sign is called a column. You can use it to represent all the zeros. So that's how to short IPv6 address. All right, am I correct? So I am going to use this one for the first PC. I will copy and paste because to type it, maybe I'm a bit lazy here, so I'm going to do copy and paste. All right, but you can equally type it if you get time to do that. So I go to the PC, click on it, go to config, go to the ETA 0, then you see IPv4 IP configuration. This first side is for IPv4, while the lower one, they write it IPv6 configuration. We are using static, so I'm going to click this box, then right click to paste, but equally you can type it something like FD D8 column, but I've already pasted it, so no need. Then instead of writing the subnet mask of IPv6 address, you use slash instead of using the normal subnet mask of 255.255. so this will make it a bit easy. So by default, IPv6 addresses, if you do not subnet it, it uses /64 mask. So I'm using the classless, I'm using the default classful range now, so I do not subnet it, so I'm using the /64. all right, then that's all for this PC. I will also go to this PC to do the same. I'll just paste it and change the last quartet, the address. So go to ETA 0, then right click, then change it to 3. Alright, then /64. You notice something here? I didn't put this IP address. It was there before, so that is the link local address. Is a type of IPv6 address that is always automatically enabled as soon as you enable IPv6. So I told you about that earlier, so you are not the one to configure that. So I've already assigned this one. The next one is the PC, sorry, it's the router. So go to the CLI. I'm not accepting any initial config, so I'm going to write no, enable. So let me first of all show IPv6 address. Show IPv6 interface brief. Sorry, interface brief. So see the command to view IPv6 addresses if you configure anyone. So I have not configured anyone. Alright, so there's no one here. Unassigned. Alright, so let me assign one to that interface G00. So go to interface, enter configuration mode first, config interface G0/0/0. Okay, let me test something. Before I assign this IP address, let me ping that IP address and see if it will go through. Let me check the list again. We have assigned this one to one PC, we have assigned this one to another PC, so we are assigning this one to the router interface. Why do we use this address for the router? The instructions say that we should assign first usable, so second usable, and last usable address. So this is the last usable address of this range. Why is it the last usable address? Because the rest bits, all the other bits are supposed to be 255.255.255. The last one here is supposed to be all F also, but if you use the all F, that means some protocols may be using that all F. It's just like the broadcast address in /20 in IPv4, so using 255.255.255. so all the last one will be for broadcast. But in the case of IPv6, there's no broadcast address anyway, but other protocol may be using that f.f all f.f.f.f. So in that case, one less than the last address in that network, which is fff.e, ffffe will be assigned to the interface rather than all f. Okay, so all these portions are for the network, for the interfaces. That is the interfaces identifier. Every other ones are the network portions, so that one doesn't change, but the interface identifier will always change to identify different interfaces. For example, these ones are all 0, double colon represent all 0. So because we are using a lower part of the address, we are using 002 003, but I want to use the last available address, so I change all the 0 to fff. So in hexadecimal, fff is the last value in the hexadecimal, which represent 15. Alright, so then this e is 14. That e is the next to the last available address, ffffe. Alright, so I'm going to give this address to the router interface, but before I do that, let me ping it if it will go through. Alright, right click to copy, so I'll ping it from the PC. So go to desktop, command prompt, the command is still the same, ping, then followed by the address, right click to paste. So I paste it. Sorry, why is it copying this one? This is not the right address to copy anyway, so let me go back again and copy. I want to copy this address again. Control C. Alright, as you can see, the ping is not going through. Of course it will not go through because I have not assigned it. So let me go back to the router and assign it again. Okay, so click on the router. So the command to assign IPv6 address on the router interface is IPv6 address, then followed by the address. Right click to paste, then put /64. Alright, I will unshut the interface, so no shut. Then do right to save.
Is young Fred the dangerous producer?
Alright, so let me go back to those to the PC and try to ping again if it will go through this time. Let this orange light change to green first. Waiting for the light to change to green. Okay, it's up. Let me hit the up arrow again, then click enter. You can see the ping is going through now. So let me ping from here also. Go to desktop, command prompt, ping, then right click, paste, hit enter. You can see it's going now. Okay, let me also ping the second PC from here. So ping, let me paste the previous address and edit it. Delete. Double colon, then the second address should be 2. Yep. Okay, I can reach PC 0. Let me ping this PC's address, which is 3. Then it's pinging itself. Alright, so any other thing? There's one important thing that we're supposed to do on this router before this ping go through, but I think because it's packet tracer, it just allow the ping to go through. So that thing is this command. Before using IPv6, you're supposed to enter this command before they can ping through, but I don't know, maybe it's because they are in the same network, that's why it's going through easily, or maybe it's because it's packet tracer. But in reality, when you are assigning IPv6 address to a router, you're supposed to enter this command first. Okay, so let me just enter it, even though it's working like this. Let me just enter it so we will get used to it. So let me exit here, config. So IPv6 unicast routing to enable IPv6 routing. Okay, so do right to save. So that is the before I end this video, let me ping the pieces from here also. Okay. Ping, paste, let me edit, column 1, double column 2. Okay, I can reach PC 0. Let me change to P3. I can reach PC 1 also. So that is the end of this video. That is very simple. It's as simple as assigning IPv4 addresses to an interface. The only thing you just change here is that the command, in the command you add IPv6 IPv6 before the address, instead of just saying IP address. So you just include IPv6 address before you type in the actual IPv6 address on the interface. And instead of using 255.255.255 as a subnet mask, you just use slash, then followed by the subnet you want to use. Alright, so using /64, the default one, without subnetting it here. So the subnetting is also simple, just borrow bit. In that case, you have to convert all these hexadecimal value to decimal, then from decimal you further convert it to binary. Then with the binary you can borrow bits and then you can subnet. Alright, it's also simple, there's nothing big about IPv6 addressing, but some people are scared about it because they heard the name and you see the value so long. Alright, you can short the address, as you see here, those long address can be shortened. Also, that's the end of this video. Always remember to like and subscribe to my channel and share with friends. So thanks for watching once again.